Okay, this video goes with the 6.1 notes in the packet, Angles of Polygons. It was originally written for the Prentice Hall Text 7.1 section. So first off, the sum of the interior angles of a polygon based on the number of sides adds up to n minus 2 times 180, where n is the number of triangles that you can form. So as an example, I can draw a diagonal from C to A and from C to E and break this triangle or this pentagon up into 3 triangles. The original number of sides is 5. The number of triangles is 2 less than the number of sides, and each triangle has 180 degrees worth of angle measure. So altogether, these angles are going to add up to whatever 3 times 180 is, which is 540. Because it's a pentagon. Hexagon would have 6 take away 2, or 4 times 180 for the number of degrees. Sketch a hexagon real quick. 1, 2, 3, 4, 5, 6. Hexagon. 6 sides. 6 take away 2 times 180. Number of triangles. 1 triangle. 2 triangles. 3 triangles. 4 triangles. 1, 2, 3, 4 triangles. 4 times 180. 720. For n is equal to 6. This one's n is equal to 5. Okay, let's move on. Find the measure of each interior angle of this pentagon. So altogether, these inside angles need to add up to 540 degrees, because 5 take away 2 is 3, and 3 times 180 gives us 540. And if we add up our x's, we have 10 x's. And if we add up our numbers, we've got 170. So 10x plus 170 equals 540. When we simplify, we get that x is equal to 37. So each angle, h is going to be 74, j is given 142, k is going to be 74, l is going to be 3 times 37 plus 14, which is going to be 125, and the same thing for m. So example 2, here we have a quadrilateral. Now with a quadrilateral, we can break that up into 2 triangles. 4 take away 2 times 180, which is 2 times 180, which is 360. So all these angles need to add up to 360 because it's a quadrilateral. This is a 90, another 90, and 4 x's. So 4 x's plus 90, plus 180 rather, makes 360. Take 180 away from both sides. 4 x's is 180. X is going to be 45. So this angle is going to be 45 degrees. This angle is going to be 135, which is 3 times 45. And altogether, these are going to add up to 360 degrees. So good example 3 here. We have a regular pentagon. It's regular because all the sides are marked as congruent and all the angles are marked as congruent. So in a regular pentagon, we have 5 equal angles that need to make up the n minus 2, or 3 times 180 number of degrees. So there's going to be 540 degrees inside this pentagon, and we have 5 equal angles to make up that 540, so we get 108 degrees for each one of these angles. And our formula for each angle in a regular polygon, based on n being the number of sides, is n minus 2 times 180, which is the total number of degrees, divided by the number of actual angles, which is the same thing as n. So 2 less than the sides for the number of triangles times 180, and 1 angle for each side for the number of vertices. So it came out to be 108 for this one. Now, those were interior angles. Let's talk about exterior angles. The exterior angle sum, one at each vertex. Each one of these angles has to add to 300. Well, all the angles together add to 360 degrees. That's our rule. So let's look at example 1. Here we have a quadrilateral. There are 4 angles, but it doesn't matter. Those exterior angles, one at each vertex, needs to add to 360. We have 17x's plus 139 equals 360. When we simplify, take 139 away and divide by 17, we get x is equal to 13. And all we had to do for this one was find the value of x. Let's look at example 2. Find the value of x again. More exterior angles. All of these exterior angles, not these inside ones, those are just there to confuse us. But if we look at the exterior angles, these all need to add to 360. There's one at each vertex. So we get a total of 18 x's, and the number parts cancel out. 18 x's is 360, so x is equal to 20. And we could actually see what each one of those angles needs to measure. And they do all add up to 360. And that's it.